Should be there all that. Ayushman. Ananya is absent. Jaishnavi is present. Gaurang? Gaurang is here. Oshika is here. Rajvardhan? Roni? Anish? Make sure that your mobile phones are absolutely silent. Okay. Anish, would you like to come and sit here? Are you okay there? I don't mind. If you sit there, you are okay. But I don't want you to be disturbing others and disturbing us. But if you are getting disturbed, please come and sit here. I've given you an option. Right? Any idea why the girls are not coming?
Mama, we are having a match. Football match. No answer about
Roni. Okay. So, what is the last thing that we have done? Some homework I have given you. Of course. No?
Yes. You are intense question.
Yeah?
Intense question.
Yeah. Not only in text. Diagrams, I said we'll be starting with the convex, no?
Yeah.
We have finished everything about the mirrors. Right? Mirrors we have completed. Ray diagrams are over. Sign convention is over. Refraction of light. We have done about the glass slab is over, right? We have spoken about the refractive index, correct? Correct? Yeah. Prashita, show me your book. What was the last thing that we have done? Yeah, example we have done. See? Homework, that is why I said leave a blank page so that you remember. What was it? Show the laws of refraction and also to draw. Why is it that here this is drawing? I wanted you to draw tracing the path of light. You were absent, I know that. You were present.
I have done the laws and
You have written?
yes, I know what the
You've done. Okay. What about you, Anish?
I did the first lecture of physics.
Oh, that's what. You can do it by next class. By Wednesday's class, everybody will be able to do. Okay. What about you? Yesterday have you done? Diagram also you have done. So that was what we did in the class. I wanted you to trace out the path of light in a glass slab. Yeah. I'm particular. It's better. It's high time that people wake up, huh? And right now there's not much going on in school. So you better finish learning these chapters right now. When I'm teaching, it may be simple for you, but when you actually give your test papers, you will realize for each this thing you don't want you to lose marks. Okay, so please be very particular about the homework. Today we'll be starting with ray diagrams. Ray diagrams we have not yet started, right? Convex lens. Yeah, because last Wednesday, is it uncomfortable for you? You come here if you don't want, or you want the AC. You shift, no, you can shift and sit there. You can shift and sit there. All of you want?
yes.
Okay. All of you want, then you can switch it up. I have no problem. Better only use this one. Okay, come on, let's start. Ray diagrams. Now we are talking about lenses. Okay, ready? How will you be ready? When I say get ready, everything should be ready. Your scale and ray diagrams, pencil, everything. Now, once again, remember, we have talked about convex lens and concave. Okay, for concave I've got only 2 diagrams, for convex lens we have 6 diagrams, right? So how do we start? Always start with the principal axis, draw a thin convex lens, okay? Then from O is your optical center, we will mark the F1 and F2. Measurements should always be from O. Okay, ready? Did you draw? Hurry up then. So we will, for the ray diagrams, once again, just like your mirrors, we will use 3 rays. Children, right now, there's no need for you to be using this. Okay, you just take it roughly, otherwise it will take a very long time. Whenever you draw a lens, make sure that it is not really bulging. So for thin lenses, this is valid. So one of the first things that we'll talk about is this is O. We'll write F1, this is your F2. So a line which is parallel to the principal axis. Is it undergoing reflection or refraction? Refraction. So after refraction, it passes through F. So it will pass through F. So this is one of the rays that we will take for drawing our ray diagram. Is that your physics? Oh, because you have forgotten. Why don't you do nothing? Take a double sheet and afterwards paste it back. That is okay with you, either which way. But do it neatly so that you can just stick it back. Okay, middle page and stick it back. Yeah. Write it down. No, don't tear. Don't tear. Write it to that and then afterwards you get it. Okay, second ray. I'm talking about the second ray. Once again, we will draw the principal axis, right? Draw a thin lens. I'm talking about the convex lens. Show O, F1 and F2. Rajmatan, what is your guidance? Come on, fast. Right? If I'm having a ray passing through F1, a ray which is passing through F1, after refraction, what do you think is happening? When refraction is taking place here, it will become parallel to the principal axis. Okay, I'll be using 2 colors for you to understand that there's a refraction taking place. Did you notice that these are very similar? Show the arrowheads. Arrowhead here to show that it is incident ray. This is your refracted ray. Okay. Third, if I'm having a ray passing through O, What do you think will happen to a ray passing through O? Will it suffer refraction? Very good. It passes through in a straight line. There is no refraction. Okay. So it is passing through without any refraction. The lens has to be thinner.
My diagram is good.
No, I'll show you how it needs to be done. Yes, it has to be absolutely thin. Otherwise, this will not be valid. Because refraction is taking place at both these places. I have to show you. Look at the board. Everyone look at the board. Why I am insisting that the lens has to be thin? Suppose I draw a very thick lens like this. We are talking about a ray of light. This is air and this is of course glass. When a ray of light is passing, let us say it's parallel to the principal axis, it's passing from air to glass. So it is bending towards the normal, isn't it? Once again, it's bending towards the normal. Here again, there's a refraction taking place. It will bend away from the normal. So refraction is taking place at two places. Do you understand? Similarly, when we take, on the contrary, if I take a very thin lens like this, for all practical purposes, what am I going to say is the refraction is taking place at one point. We are going to take both these refractions into consideration. Did you understand? Here it is from rarer to a denser medium, from a denser medium again to a rarer medium. We are never going to be drawing a diagram so much in medium. Okay, that's okay. That's what you're doing is fine. But don't ever draw something that's this thick, right? Because we are going to show only one refraction which is taking place. You get it? So it's an overall, an average refraction is basically what we are looking at. So, have you all taken it down? So these are the three rays that we will be considering for drawing our ray diagrams. First one is object and infinity. Okay, so draw. Maybe you can take 2 or 3 lines above and make it a symmetrical convex lens. O. From O, take measurement of F1 and twice this will be 2F1. Similarly, here it is F2, here it will be 2F2. I'm sorry, I didn't have the important number.
This is
Where is my object? Object is an infinity. That means it's very far away. That's your first diagram that I'm drawing. Ready? So it may be a tree or it may be an electric pole or something which is very far away. So I'm just going to draw a ray coming from far but parallel to the principal axis. So this is your incident ray. After refraction, where will it pass? How will it pass? Passes through F2. Yes, it is passing through F2. So this is the refracted ray passing through F2. I'm going to take another ray, once again parallel to the principal axis, coming from our distance. Object is very far away. Draw this. What will happen here now? Once again, it's a refraction taking place, passing through. Once again, passing through. Did you see that we have combined the first and the second rays that I have given you? Did you see that? I have given you 3 rays now, out of which we have combined the first ray and the second ray. So where do you think your image is formed? Image is formed, right? So now we will write about the image. Now I am writing about the image. I'll write the position size and nature. So wherever we find that the rays are intersecting, that is where your image is formed. Okay. What type of an image will it be? Position will be, it is at F2. Right. At focus. What will be the size? It will be very small. Okay, it is highly diminished. It's highly diminished. Highly diminished. And what will be the nature? It will be real and involved. Is that okay? Is that okay? You have seen the magnifying glass? You have seen the magnifying glass, isn't it? Suppose that's the sun, right? Sun rays are falling and you're keeping your paper here, such that you get a bright spot on the paper. What will happen to the paper? It will start burning. So what are we getting here on the paper? It is the image of the,
On Friday or Thursday, I tried on school work, it didn't happen.
maybe the angle was not correct. Just make sure that this angle, so the sun rays try to capture it properly. You should get the sharp.
Yes, so I was getting it.
You should be able to keep it for some time. You will get, definitely you will get. Okay, you get the sharp spine. That is nothing but the image of the sun. So it is going to be real and remote. Is that okay? Yeah? Ready? Look at your textbooks, everyone. So what we have done right now is this diagram. The first diagram. Put a tick mark there. Okay. The first one. Did you notice that they have drawn so many rays? Okay, 4 rays, 2 rays above, 2 rays below. I have not drawn all that. I've just taken only 2 rays for us to understand. Okay. Now if you go to the previous page, did you notice that there is a table here? All of you look at this green table here, right? Keep your book here. First diagram, put number 1 there. Object is at infinity. Position of the image is at focus F2. First one, you see, it is at infinity, it is given. What is the size? It is highly diminished, or you can also write it as point sized. Okay? And the nature of the image will be real and infinite. If you have your volume, you can take it out. Anush, you have your volume? Yeah, you can refer to the volume, no problem, it is given there. You also have your volume, you can refer to the volume. Both are yours. Right. Is that okay? Did you understand this? Right? So, we have also drawn the diagram and we have also completed the written part. Right. Come to the next one. Look at the board, everyone. Look at the board. Object was very far. Right? That was our first position. Object is coming closer. Where is it? It's not at 12. It is not at 12. It is beyond 12. Okay, it is just beyond 12. Now I am coming closer. Where does it come? At 12. So that's your position number 3. It is coming closer. Between 12 and F. Now
At
F. Okay, and now
between
that is within the focal length. Did you notice? The last one is between F and O. That means this is the focal length. So how many positions do we have? 6 positions.
I'm three on this side and 3 on
No,
that side.
no. Always the object is on this side. The object is always on this side. Always here. So object is at infinity. Object is at 12. Beyond 12. That is position 2. At 12. Between 12 and F. And F. and between. So the position of the object is always on the left hand side. Okay, right? Now, if I'm talking about the object distance, it will be between the object and O. Okay, so it's going to be U. U will be positive or negative here? Negative. It will always be negative because object is always going to be kept on the left hand side. Is that okay? Remember the Cartesian signs that we have learned for our mirrors? The same thing is going to be applied here. Okay, come to position number 2. Once again, draw your principal axis. You can draw a thin convex lens. Mark it as O. We have our F1 and 2F1 exactly at this distance. Similarly, we take F2 here and 2F2. Okay? So now our object has coming closer. It is beyond. I'll write here. The heading for this will be object is beyond F1. So I'll go to draw something here like this. Okay. So we are going to take ray number 1 and ray number 3. Let's see what happens. First ray parallel to the principal axis. This is your incident ray. What happens after refraction?
It passes
through
F2.
Okay. It passes through F2. Let's say it's passing through F2. What does ray number 3 tell us? Passing through O. If it is passing through O, what will happen? Take your scale and draw this.
It goes straight.
Yes, pass through O without any refraction. Draw a scale and pass it through O. Do this completely. Okay. Where did you get your image?
Beyond F2.
Beyond F2?
Between F1
Between
and
F2
F2 and
Ah, between F2 and 2F2. You will get somewhere here.
It will also highly diminished.
Not highly diminished, it will be smaller. You can say it is diminished. Did all of you get it correctly? You have to practice these diagrams, okay? Using your geometry. Use a scale and proper measurements and stuff. So we'll talk about the position of the image. The same 3 things: position, size, and the nature. Position here, it is between F2 and 2F2. What about the size of the image? Diminished. Okay, it is slightly smaller than what we have taken here. Suppose you have taken 2 lines, you will find that this is smaller than the 2 lines. Okay, so we can write size will be diminished. What about the nature?
real and inward.
Yes, real and inward. If it is real, obviously it is going to be inverted. Okay. What else is missing? What are the things that we have to be careful about? Arrows are very, very important. Show arrowheads for the incident ray, okay, the refracted ray. Okay. Also mention AB here. AB will be your object. Right? How do we show it as an inverted one? Like this. So you will show it as A dash B dash. Right. A dash B dash. Did you get it, girls? This is AB. When it is inverted, this becomes A dash B dash. So here you will write it as A dash and B dash. What do you think the position number 3 will be? Diagram number 3. Okay, now we have already come till beyond 2F1. Now where is the position? At 2F1. So the third position that we will write is object at 2F1. Okay. Now this is where your measurements have to be very, very accurate. I am drawing an object which is placed at 2F1. Let's take ray number 1. What is that ray? Ray parallel to the principal axis, passing through. Yes. Let's do that first. One ray parallel to the principal axis and passes through F2. Done. Okay. Now here you will remember that if the object, listen to me, if the object is at 2F1, the image will be formed at 2F2 if your diagram is accurate. Okay. So the next ray will be passing through O, straight line without any refraction. Okay, so I go ahead and object is here, the image is here. This is your image and this is your object. What did you notice about the size? It should be the same size if your diagrams are accurate. Okay, because it's a diagrammatic geometrical construction. If it is accurate, you will find that the size of the image is same. Once again, we write down about the image. So we write position, size, and nature. What is the position of the image? Where do we find it? At 2F2. Okay. So position is at 2F2. If you're not getting the size, the same size, you will have to wrap it out and repeat it again. Anyway, all these diagrams you have to do it once again properly. Okay. So what will be the size? The same size as object. So if this object is 2 centimeter, the image will also be 2 centimeter. Is that okay? Finish, Rajwardhan? The lens is so small. Lens always make it 2 or 3 lines. That should be okay. It has to be symmetrical. Suppose you are taking 2 lines above the principal axis, take 2 lines below the principal axis. Okay. The next time it's from the first. Use the reference as the line. So if it is, if this is your principal axis, 1, 2, 3 here. You have taken only 1, 2 and third one it has not come. Okay, so 3 lines below, 3 lines above. Okay. What about the nature?
Use an inverted.
It is real and inverted. So here again we are getting real and inverted. So we have finished the first 3. What is common here? What did you notice? Nature. Nature is always real and inverted. Now I'm asking you a question, everyone. Okay, because these are going to be useful when you're going to solve the numericals. Let's look at this diagram. Where is the image formed? Either here or here. Where is the image formed? Left hand side, right hand side. Okay. So V is the image distance. Starting from O to B, this is your V. Is V going to be positive and negative?
Positive.
It will be positive. Did you all understand?
Yes.
You will always be negative because object, we are always keeping it on the left hand side. Is that okay? What about focus? Is it going to be positive or negative? Look at the first diagram. Where is the focus here? Always positive. Okay, for a convex lens, it is always going to be positive. Is that okay? Right. So we know about U, we know about V, we know about F. Now what about H1? Is it going to be positive or negative? Height, यहाँ से यहाँ तक. It is above the principal axis. So what will it be? Positive. You remember? Okay. Object will be height. So we measure height from the principal axis. For height, we don't consider whether it is left hand side or right hand side. Height is always one. Okay. Here, where is it formed? How is it formed here?
Below.
Below. So how? What will you take H dash as negative? Suppose it is 2 centimeter. What will you put it in the sum? Minus 2. Did you understand here? Okay. Suppose it is 3 centimeters here. Okay. What will be the size here?
Minus.
Height. Height will be minus. Did you understand? This is 3 centimeter H. H dash is also going to be 3 centimeter. But in sum, when you put it down, you're going to write it as minus 3 centimeter. Are you clear about all these things? Okay, because these are the ones that we are going to. We have finished position number 3. All of you can put a tick mark there. See here. Position number 1, 2, and 3. Write it there. Write it in your textbook.
You said U will be negative, right?
Correct.
Why? Because it is
U is left hand side. You remember this is left hand side and this is right hand side. Okay. Measurement anything from the left to O will be taken as negative. Any doubts? Any doubt? Now we have already come to F1.
The object above the principal axis will be positive and below will be negative.
That is H, not U. Okay, not U and V. U and V is the distance that we are covering. When we talk about H, it is perpendicular to the principal axis. Okay, and above the principal axis and below the principal axis. Now tell me what is the fourth position? We have already present, we are already at 2F1. I'm moving closer. So between 2F1 and F1. Do you think the image will be bigger or smaller?
Enlarged.
Enlarged. As the object is coming closer and closer towards the lens, this is becoming bigger and bigger. Okay, come on, let's draw this. Object is, what did you say? It is between, yes, between F1 and 2F1. So draw, that's O. not try to do it. Graduate finished. Is diagrams over? This one. Fourth diagram, we are talking about the fourth diagram. How will you indicate the object? You write it as AB. One line parallel to the principal axis, put an arrow in, incident ray. This ray will pass through F2. Which ray shall we take now? A ray passing through O. Okay? So it will go without any refraction. Draw the second ray. Another ray passing through O. And tell me where it is going to happen. What is going to happen?
My image is forming at 2F.
It will not form at. उधर हो गया ना? 2F हो गया वहाँ. This is already done. So it has to go beyond this.
Beyond,
Yes.
beyond 2F2.
It will come beyond 2F. Okay, so if you extend this as a straight line, you will find that it is beyond 2F2. Have you taken the measurements correctly? This measurement, how much is it? Did you use your scale and take it? You use your scale. Okay. Suppose you are taking 2 centimeters. 2 centimeters. Next one, you put up here. A dash, B dash. Okay, let's write about the position, size and nature. What is the position here? Beyond here, figure number 4.
Between F1 and
Object is between F1 and 2F1.
F.
I'm talking about the
beyond
image.
2F2.
Yes, is beyond 2F2. Size will be bigger or smaller?
Enlarged.
Enlarged. It's now becoming bigger and bigger. And nature will be once again real and important. Okay, where do you think we are going to be using this? Everybody please pay attention here. We want the image to look big. So when we go to the cinema theater, we find a screen, no? Right? So the image is formed on the screen, which we can see the actors and actresses. Girls, pay attention here when I'm explaining. Okay, this is used in a projector, right? But how is the film? Is it ulta here? Because we are seeing it is real and inverted. How do we find actors on the screen? It's going to be straight. So what are they going to do? This part of it, they will put it as an inverted one. So the image will look upright. Yes. So write down here, used in camera projectors. Come on, write down. Because you want an enlarged image. Sometimes such type of questions will be asked. Okay. At which position should it be there? At which position the slide should be kept here?
How is it used in?
Camera projectors. For the in cinema theaters, we have the projectors, so that is very easy. Okay. So now we come to position number 5, and our object has already come to between 2F1 and F1, so obviously it is going to be at
I'm used in
camera projectors. Where do you think we have did this?
Beyond or between?
Where? Are you getting confused here?
No, you're okay.
This is the image. Okay. So now we have to draw this part. Our object is now at F1. Did you draw? One ray, incident ray passing through the, yes, through the focus. So this is one ray passing through the focus. And the second ray passing through O, you'll find that it's parallel. So the image is from somewhere very far. Because it's formed very far away, I'm just going to put dotted line to show that it is still extending somewhere there. What about the position where you think it is formed? At infinity. At infinity. Size will be extremely large, highly enlarged. And of course, nature will be real and infinite. Finished? Not yet today. I'm finished drawing. Today you're in a, you want to wash your face and come? If you live in that, people should have. Yeah. Children, I want you to do it accurately once again at home. That's the rest will not be accurate. Now, this type of lens is used in highly specialized laboratory equipment where you need to have a parallel beam of light. See, did you notice here? Did you notice here? This beam is parallel, correct? So in spectrometers, in collimeters, we use such type of, lens to give you a perfect parallel beam of light. So far, we have noticed something that the nature is always real and inverted. Okay, we come to the last diagram, which is going to be diagram number 6. Here is a special case, so I'm putting a star, and object is between
F1 and
yes, between F1 and O. That is, it is within the focal length. Such type of questions are usually asked in word problems, so that is why I put a star there for you to understand. Okay. Let's see how we are going to draw. One line, draw the lines. This will be O, F1 to F1. Okay. Not infinity, you will not find it. You will see. Yeah, it is diverging, then we have to extend the line behind. Correct. Draw it here. Have you all drawn? Don't get confused because I'm going to do it stepwise, so all of you do it along with me. Are you ready till here? One line which shows that this is the incident line, passing through F. Okay, passing through focus, that is your F2. Okay, and the second line is also passing through O. Okay, so the second line is passing through O, and we find that these two are moving away. Okay, so obviously it's not going to meet anywhere. So what are we going to do? Extend this line behind, extend this line behind. That means we are getting a virtual image. Correct? Have you drawn till here? Very good. So we extend this line without, right, using your scale. We are going to draw this. We are going to draw this until it somewhere, sort of.
V out to F1.
It's somewhere on the same. It need not be. It depends upon where I have kept this. Okay, it could be here, it could be here, it could be here. So all the position what we'll write is on the same side as the object. Object is kept here. The image is also formed on the same size, same side as the object. So because it's a virtual one, virtual image, I will not draw a straight line. I'll put a dotted line like that. What does it show? It shows that this is a virtual image. So here nature, what will you write? It is virtual and erect.
You can also write magnified.
Yes, we'll write position, size. We will write all that. What will you write for position? It is on the same side. Yes, on the same side. As the object. And what do you think will be the size? Obviously, it is so enlarged, it's magnified. It is enlarged. Or you can also say it is magnified. I'm using this word magnified. Where do we use such type of glasses? Use this word. Magnifying glasses. Okay, it's magnifying glass. So when you're having a magnifying glass and you want to read some print which is so small, what am I going to do? I'm going to keep it close to it. Did you understand? Microscope also uses it. Yes, but microscope uses a double convex lens. There's one convex lens which is known as the eyepiece and the other one is known as the objective. Okay. On the objective, obviously, it has to be very close to the slide that you prepare. Maybe you have kept the spiral diagram or you must be seeing some sense of the flat or whatever it is. Yeah, so it has to be very close. So it is your image. Is that okay for all of you? Did you understand? Now I want everybody to pay attention to this part. Okay. Where is our object? Put your pens down and listen to me very carefully. Object. So we will write it as edge. Okay. Object is what? Edge. O. Will it be positive or negative?
Positive.
Why is it positive? Because it is above the principal axis. So H plus HO will be positive. What about your dotted line? What is it showing you? Height of the image. Is it positive or negative? Positive. Right? Because this is also above the axis. So in this case, both of them are positive. Did you understand? What about U? Tell me about U. Negative or positive? U is your object distance.
Negative.
Sure? Everybody says it is negative? Correct. It's going to be negative. What about V?
Positive.
Positive or negative?
Positive.
Left side or beta from here to there.
Negative.
From यहाँ से लेके यहाँ तक it is on the left hand side. Distance, no? V is distance. Okay, so it's going to be negative. Did you understand? Write this down below this diagram. याद रहेगा. For position number 6, they usually ask you some type of word problems. So if you have this with you, it is easy. Put a tick mark in your textbook, all the 6 images we have completed. Okay, here. Put a tick mark here. And also these images, ray diagrams of all the 6 images. For homework, right? Please leave how many? 2 pages? 2 pages, but you have to use accurate measurements. Okay? Use 2 centimeters. Use 2 centimeters, draw very accurate. Now, all the 6 diagrams are over here. Look at me. 1, 2, 3, 4, 5, and 6. 6 convex. Okay, now we are going to do only the concave. It's only 2 diagrams. Let's see what type of images are formed for a concave lens. Yes, always it's going to be virtual. Take 3 centimeter, 3 lines above and 3 lines below. See how we are going to draw? Okay. 3 lines above and 3 lines below. Make a small concave lens. Okay, this is going to be O. The first image, we'll assume that the object is very, very far away. Okay, so we have a ray coming from far off. This is your incident ray. Now we are talking about a concave lens. So is it going to be diverging or converging? Diverging, moving away. Okay. So if this light is moving away, but it appears as if it is coming from F1. So draw a dotted line here like this. See how we have drawn? Children, look at the board. Look at the board first of all. Draw a dotted line like this and then show that it is moving away. No, that lens I will not accept. It has to be a narrow lens. Cut it out. Lens has to be very narrow. Cut it out and draw it again. Okay? It should be a thin one. Are you sure yours? Make it slightly thinner than that. Show yours thinner. Slightly thinner. Yeah, this is okay. That's okay. Yeah. Yeah, that should be. Yeah. So we can check closer. We have a closer to this. Perfect. I'm just telling you what measurement. See, you have got a protractor, right? You can use this for drawing. That is true. So suppose you are having a line, you draw a line like this. And then you have to keep it this. Correct? Got it? So that is when you are going to get a perfect one. We'll continue in our next class. What I want you to draw is 2 basic diagrams of this draw and keep, and we will draw the lines afterwards. So what's for homework today?
Draw the ray diagram.
Please draw the ray diagrams. Every time you draw the ray diagrams, think about H1, H2, B, U, H. Yeah, today we have a class. We have a class on Wednesday. right?
It's chemistry, right?
नहीं नहीं.
Well, there's been a slight change in the timetable, so that's why I'm reminding you that Wednesday is also a physics class. Last week we did not have a class one, so we have to make it.
Thank you.
कैसा डेंजर?
सरेगा भाई
उसका नोट पे तो नहीं लगा ना मिसिंग नंबर ऑलरेडी.
वो बुक दे दे
हाँ बोला था मैं सुनने को
ले लेना फिर प्रेस रिलीज अब किधर मैं ढूंढ रहा हूँ खुद दे रहा खोलने को उतारना भाई गलती से दे दी अगर ले ले
क्या
तुम
मतलब?
सुनने का है नहीं मेरी बात।
गलती से क्या मतलब?
नहीं मीना ने बोला तुमको देने का तो लेगा चलो दे दो ए, क्यों? अभी उसको